Good morning everyone. This session I will be discussing more problems on Cartesian product between two sets and relation. In the last video I have explained some problems from the worksheet. We did till sum number 18. We are starting discussion on number 19 to 23 as shown here. Then we will be doing more sums based on the concept of relation, but we will not be doing types of relation in this time. That we will do in another session. So for number 19, in sum number 19, you all can see that there is a set A given, R is the relation such that AB belongs to A cross A and A is multiple of B. A means the first element. First element is multiple of second element. So what way you can take R here? It is the set of ordered pairs. We have to take elements of A cross A, I mean both A and B from this set. If we take 2, it is multiple of 1. If we take 3, it is multiple of 1. If we take 4, it is also multiple of 1. Then is there any other element? Can we take the first element as 3 and second element 1? It is already taken. So only one more case I think it is possible when you are dividing 4 by 2. So 4, 2. No other cases will be there. So relation here, the first element will be a multiple of the second element. No other possibilities are there. But we are doing one mistake here. We have taken different elements. We did not consider the case when two elements are equal. Then also first element will be multiple of second element. So you need to include 1, 1, 2, 2, 3, 3, 4, 4 also in R. So relation are written explicitly in terms of elements of the set A. Now when you are doing sum number 20, you can see that relation is given R equal to AB, where AB belongs to Z cross Z, and A square plus B square less than equal to 4. What do you mean by Z here? Z is the set of integers. Z stands for set of integers. Okay. So if Z is set of integers, you have to choose values of A and B such a way that A square B square remains less than equal to 4. They may be equal. A and B may be equal. One of them may be equal to 0. All these things possible, but remember both A and B must be integer. You cannot take any fraction, and those two integers will satisfy this relation A square plus B square less than equal to 4. Let us take the values of A and B this manner. A I am taking here, B I am taking here. If you take 0, 1, it's alright. In fact 0 plus minus 1, because 0 square plus 1 square less than 4 only. If you take plus minus 1 comma 0, then also it is valid. If you take A plus minus 2, B plus minus 2, is it valid? No. If you take A plus minus 2, then this is 0. A plus minus 2, then B will be equal to 0, because if you take any number, it will not remain less than equal to 4. Can you take any other element? Can you take 1, 1 here? 1, 1 not taken. Either 0 or plus minus 1, 0, plus minus 2, 0. Then you can take the value of A as 1, B as 1. But you cannot take one of them as root 2. If you say A equal to root 2 and B equal to root 2, then it will not. It is not possible. Because root 2 is not a rational number. Integer, so not possible. Okay. So those ordered pairs only will be writing. This relation are going to be 0, 1, 0 minus 1, 2, 0, minus 2, 0, and next one will be 1, comma 1. Okay. So these are the elements of R. R is a relation from set A to set B. Next one is very easy, just already explained. A contain 3 elements, B contain 2 elements. Find the relations from set A to set B. This was sum number 20 we did, 19 we did. Going to do number 21. A equal to x, y, z and B equal to 1, 2. Find the number of relations from A to B. So you just remember relation as set of Cartesian product. Set A cross B. Okay. Number of elements in A cross B, you know, it's going to be equal to number of elements in A multiplied by number of elements in B. Okay. So how many elements will be there in A cross B? There will be 3 into 2, 6 elements. Okay. So if we want to write a relation which is defined from set A to set B, then remember that relation will be subset of A cross B. Relation R defined from A to B is a subset of A cross B. Okay, but here A cross B contains how many elements? A cross B contains 6 elements. And if a set has n elements, number of subsets you know 2 to the power n. Am I correct? If a set has 2 elements, how many subsets are there? This you did before. 2 square, 4. If it contains 3 elements, how many subsets will be there? 2 cube, that is 8. If it contains 6 elements, then how many subsets will be there? And that will be relation. Any subset of Cartesian product set will be a relation from A to B. So required number of relations equal to 2 to the power 6, that is 64. In total 64 relations are possible over there. Okay. So let us solve. Actually this 64 number of relations mean null relation, universal relation, it containing only one element, 2 element, 3 or their combination, all are possible. Okay. So number of relations will be 2 to the power 6. This in fact we have discussed in theory portion. Suppose number of elements in set A equal to n1, number of elements in set B equal to n2. N A cross B will be what? N1 cross N2. Isn't it? Number of elements in A cross B equal to N1 into N2. So number of subsets of A cross B or relation defined from A to B will be 2 to the power N1 into N2. Why? Because it is actually number of subsets or number of relations from the set A to B, where A cross B contain n1 into number of elements. That's why you wrote 2 to the power 6. I relation is greater than, this is defined from A to B, write the elements of R. This is another interesting sum, but we can do it here. Number 22. RE relation is greater than means second element is greater than the first element. So R containing the elements from these two sets only. What I told that is greater than. Is greater than means second element is greater than first element. 2 2 not possible, 2 5 is possible. 2 5 2 6. Okay. Then there may be second element, no, it may be 3 5 3 6. Then there may be 4 5 4 6. Okay, and then 4 5 4 6, then 5 6. No other possibilities will be there. So uh, number of elements in R will be 4 6, 2 5 2 6, 3 5 3 6, 4 5 4 6, and one more, that is 6 comma 6. Write it properly. But 6 comma 6, is it possible? It is given is greater than. So you have to restrict up to 5 comma 6, not up to 6 comma 6. 6 comma 6 does not arise. So it will be 5 cross 6. So the relation containing 2 to 4 to 6 plus 1 7. Alright. Now how to solve this problem where A is given and you are supposed to find minus A cross C. Okay. You by definition you can write A cross B cross C, Cartesian product of three sets, in terms of ordered triplet. It was ordered pair, but here it is ordered triplet, A, B, C. Where does A come from? A come from set A, B from set B, C from set C. Isn't it? A cross B cross C. So when you are going to find, you first complete the part A cross A. Then you add another coordinate. If you write A cross A, there are 2 into 2, 4 elements possible. Minus 1 with minus 1. Minus 1 with 1. And then that is, we are taking minus 1. 1, 1 is possible. Minus 1, minus 1. 1, 1 also will be there. It's alright. So if we combine, it will be minus and 1 minus 1. Yes, that also will be there. 4 elements will be there A cross A. Obvious. This is 1 comma minus 1. Now the question is how to find A cross A. A contains those two elements only. When you are taking cross with this Cartesian product, then you will write it in this manner, minus 1, minus 1. First one you give this minus 1. Okay. You can give this plus 1 also. So minus 1, minus 1, 1. Minus 1, minus 1, 1. What about the second element? This second element again the same manner. Once minus 1 will come, next 1 will come. So it is minus 1, 1, minus 1. And then it will be minus 1, 1, 1. Okay. But the thing is that here you have taken till the second element. 2 more elements are there and you have to apply the same procedure. We take 1, 1 here and any one of these two. So options will be like this, 1, 1. Wait a minute. I have taken enough space over there. The lack of space, I am writing this thing here. It was till this is taken minus 1, 1, 1. And next one will be this element. So 1, 1 minus 1, 1, 1, 1. Alright. Then you take 1 minus 1, 1 minus 1 minus 1, 1 minus 1, 1. Done? Alright. So this way you can get A cross A. Now when you are solving number 38, find A cross B intersection C. You find B intersection C first. Intersection of these two will give you only one element, 3. Now if you find A cross B intersection C, it is going to be, A means what? 1, 2, 3. cross, then B intersection C you did not, you found 3. So this will be 1, 3, 2, 3, 3, 3, and next one will be, but it is over, because you can take 1 with this 3, 2 with this 3, and 3 with this 3. No other element possible. So it is found A cross B intersection C. Now how to solve sum like number 39? We are not doing those sums based on types of relation, but based on Cartesian product and relation we are doing now. So we will continue doing sums based on the concept of Cartesian product and relation. Here in sum number 39, A and B are two sets. A and B contain 6 elements. 3 elements are given. So when you are saying that n A cross B equal to 6, then how many possibilities are there? Na equal to 3, nb equal to 2, or na equal to 2, nb equal to 3, or na equal to 6, nb is 1. Then their product going to be equal to 6. So all these possibilities are there. Now look at the relation. 3 elements of A cross B, not relation, just 3 elements of A cross B given. You see it is 1, 2. Just a minute. It is 1, 2 or 1, 4, something like that is given. Then 2, 6, 3, 6. Number of elements in one element, one set. Oh my God, this is not 2. You take this one 4. Okay, this 4 is not there. So A cross B, you got how many elements? 3 elements. Now you see the first element of these 3 are 1, 2 and 3, and second elements are 4 and 6. So this fulfills the condition. You stop your calculation here, you just write A equal to 1, 2 and 3, and B equal to just these 2 elements 4 and 6. Alright. Now how to solve these kind of things where A, B, C are given this manner, and you are supposed to check whether this is a relation from A to B or not. R1 is given 1A, 1B, 1C. A contain 1, 2, 3. B contain A, B, C. Every time you draw the arrow diagram, you just check mentally whether it is a relation from A to B or not. A contain 1, 2, 3. Here R1 just one element taken. A, B, C all 3 are there. So second elements will be taken from B in A cross B, and first element will be taken from this set. So 1 is there, that's why it is a relation. What about this thing? 1C, 2B, 2A relation. B2 is not possible because B is not belonging to A, as this B not equal to A. R4, is this a relation? 2C, 3C, 4C? Yes, it is also possible. 2, 3 are used. No, 4 is not there. This 4 is not there, so this is not a relation, as 4 does not belong to A. Okay, so this is not possible. Say fifth one, 1D, 2C, 3A. It is possible. It is possible. It can be a relation because 1, 2, 3 have taken from this, and second element DC also taken from. No, D is not there, so this will not be possible because D is not included there. No, here it is ABC. So you eliminate D. Okay.